Good morning, one and all. God bless you. Welcome to online class and as well as welcome to the maths class. Business maths and statistics. Second volume, 7th chapter is probability distributions. Probability distribution. The probability distribution, before start, I give some introduction about this chapter. The frequency distribution are of two types, namely observed frequency distribution and theoretical frequency distribution. The two types of frequency distributions are you have. The first one, observed frequency distribution, and second one is the theoretical frequency distribution. The distribution based on actual data and experimentation are called observed frequency distribution. Basis on actual data and experimentation is called observed frequency distribution, and other hand, the distribution based expectation on basis of past experience is called theoretical frequency distribution or probability distribution. The distribution based expectation on basis of past experience is called the theoretical frequency distribution or probability distribution. So, past experience. Okay. You have two types of distribution. One is discrete probability distribution and another one is continuous probability distribution. The two types of probability distribution you have: discrete probability distribution and continuous probability distribution. The Poisson and binomial distribution are discrete probability distribution, and normal distribution is continuous distribution. Here, one person name is a German mathematician. Not only mathematician, he is physicist. Okay. He was more significant contribution on the field of maths and science. Also, the probability distribution, most of the part derived he. The name of John Carl Friedrich Gauss. He was born on 1777 April 30 and he died in 23rd February 1855. The definition of binomial distribution: a random variable x is said to follow binomial distribution with parameter n and p. Parameters n and p if it assume only non-negative value and probability mass function p m f represent probability mass function p of x is equal to small x or p of small x equal to set of all ncx p power x q power n minus x, and n is equal to 0, 1, 2 and so on n. Okay. Then otherwise 0. Okay. This is your definition, binomial distribution. A variable x is said to be follow binomial distribution with parameter n and p to assume only non-negative values. Only the non-negative values assumed. Then the probability mass function p of x is equal to ncx p power x q power n minus x. For all n is equal to 0, 1, 2, 3 and so on n. Otherwise 0. And also you have condition p plus q equal to 1. So this is p represent the number of success, q represent the number of failure. Number of success plus number of failures equal to 1. This is your probability result. Okay, have you understood the binomial distribution definition? A binomial distribution definition is a random variable x is said to be follow binomial distribution with the parameters n and p. If it assume only non-negative values, then the probability mass function p of x is equal to x equal to p of x. The condition ncx p power x q power n minus x, and n is equal to 0, 1, 2 and so on n. Otherwise n values are 0. Then the condition is p plus q is equal to 1. This is binomial distribution. Another one, discrete probability distribution, is Poisson distribution. Poisson distribution. The same definition here exists. A random variable x said to follow a binomial distribution with parameter lambda. If it's assume only non-negative value and probability mass function p of x comma lambda, because here parameter lambda, so p of x comma lambda or p of x is equal to set of all e power minus lambda, lambda over x divided by x factorial. Okay, so all lambda is greater than 0, then 0 otherwise. That means the lambda values get negative, the probability mass function is 0. This is your result. Okay, this is the definition of Poisson distribution. The Poisson distribution definition is a random variable x is said to follow binomial distribution with parameter lambda if assume only non-negative value and probability mass function p of x comma lambda is equal to p of x equals to for e power minus lambda power x divided by x factorial, and the condition lambda greater than 0, as well as every x value 0, 1, 2 and so on. Okay. Every x values are taken from 0 to 1, 2, 3 and so on. Then otherwise 0. This is your definition of Poisson distribution. These two are taken from the discrete probability distribution. Another one, you have probability distribution. This is taken from continuous probability distribution. The name of normal distribution. Okay, dear students. Next, derivation of the mean and variance of the binomial distribution. So this is the important 5 mark. So listen carefully. Derivation of the mean and variance of the binomial distribution. Variance of binomial distribution. So derivation is most important question. Okay. First find out the mean. This notation is expectation of x. Expectation of x. The e can be read as expectation. So already I told expectation of basis of past experience is the probability distribution. So expectation of x equal to summation x is equal to 0 to n, then x. This is expectation formula. Expectation of x formula. Summation x is equal to 0 to n, x into the binomial distribution n cx. Sometimes write ncx this line ncx p power x q power n minus x. Okay, this is the expectation of x formula. Okay, so we want to find the mean value. Mean value. Expectation of x equal to summation x is equal to 0 to n x ncx p power x q power n minus x. Before start I gave one result. Summation x is equal to 1 to n minus 1 into x minus 1, that means n minus 1 c x minus 1 p power x minus 1 q power n minus x equal to q plus p or p plus q power n minus 1. This is one result. This is the result. So x is equal to started from 1. The n also subtracted 1. So n minus 1 and as well as x minus 1. Then p also on to minus 1. X minus 1. Okay. This like you get. We directly write q plus p whole power n minus 1. Okay. This is our result. Okay. Now consider the question. This is our form. Here apply this like this is ncx. So you get 8 factorial. How like you write 8 into 7 factorial. This is already learned our past. This is already learned our last class. So 8 factorial is equal to 8 into 7 factorial. That like here I write expectation of summation. Here I write summation x is equal to 1 to n x. This n minus ncx can be write n by x, and that means 8 factorial is equal to 8 into 7 factorial reduced to 1. So n reduced n minus 1 and x reduced x minus 1 factorial. Then p power x plus 1 minus 1 plus 1. So don't change the value. Q power n minus x. Because why I am write this like means here I want to p power x minus 1. So p power x minus 1. So here I want to use the formula. So I write here this line x minus 1 plus 1. Okay. Next. This is the power rule. So this can be write in the form of summation x is equal to 1 power n. X are cancelled. Remaining n. Then n minus 1 x minus 1. N minus 1 c x minus 1. P power x minus 1 into p power 1. Is it or not? The exponential rule. A power m into a power m plus m equal to a power m into a power n. To split the powers. Okay. So using here x minus 1 into p power 1. Then q power n minus x is same. Okay. Then so n and p power 1 means p multiplying 1 times p. So n and p taken outside, np summation n is equal to 1 to n minus 1 c x minus 1 p power x minus 1 remaining q power n minus x. Already taken out the p and n. So now consider this portion. This is your formula. Summation x is equal to 1 to n minus 1 into x minus 1 p power x minus 1 q power n minus x. This is fully equal to q plus p power n minus 1. Okay. So here np, this is fully q plus p power n minus 1. Is it or not? This is your result. Okay. Then np p plus q is equal to 1. This is your result from the binomial distribution. P plus q is equal to 1. This is also your result. So p plus q or q plus p equal to 1. So here apply 1 minus 1. 1 multiplying any times we get 1. So np only exists. This is your result. So mean of the binomial distribution is np. Okay. Okay, dear students. Next, find out variance formula. So variance of x is equal to expectation of x square minus expectation of x the whole square. This is your formula, variance of x formula. Okay. Means equal to expectation of x. That's all. But variance equal to variance of x is equal to expectation of x square minus expectation of x the whole square. Okay. So now first we find expectation of x square. This is already we have the result. expectation of x. Now only find out the answer is NP, expectation of x. So now you find expectation of x square. Expectation of x squared is equal to summation x is equal to 0 to n, because all binomial series are started from 0 to n. Then here x squared I want to find, so x squared. But the mean value find out only taken x, because expectation of x. But here expectation of x squared, so here write x squared. Then NCX p power x q power n minus x. That's all. This is your binomial series. Then summation x is equal to 0 to n, x square can be written in the form of minus x plus x. So here no big change, and this is NCX p power x q power n minus x. Then summation x is equal to 0 to n, x taken outside common term, first two term x and x minus 1, then plus x. Compare first two terms, x is the common taken outside, so remaining 1x and here 1, then plus x into NCX p power x q power n minus x. Okay, this is one term, this is one term. So multiplying this term to first term and this term multiplying with the second term. So now we get x is equal to 0 to n, x into x minus 1 and NCX p power x q power n minus x plus this term. Summation, this time also onto this one. Summation x is equal to 0 to n, x into NCX p power x q power n minus x. Understood? This term fully multiplying first one, then multiplying the second term. We get this value. Okay. So now summation x is equal to 0 to n. This is x minus x1. Here change NCX write in the form of n by x n minus 1 divided by x minus 1, n minus 2 divided by x minus 2. This is c value, n minus 2 x minus 2. This is then p power x can be written in the form of x minus 2 plus 2, then q power n minus x plus this fully is the expectation value. This is fully in the expectation of x answer. Okay, so x into NCX p power x into q power n minus x equal to NP. We already find out. Okay, so this is NP. Next, summation. Here I write n is equal to n minus 2 c x minus 2. So here change the x value, x is equal to 2 to n, x into x minus 1 and then n into n minus 1 divided by x into x minus 1. Then n minus 2 c x minus 2 p power x minus 2, this is p power 2, and q power n minus x plus np. Okay. This is same. Here I multiply n into n minus 1, x into x minus 1. Then these all are same. Here split the p values using by the product rule. P power x minus 2 plus 2, write in the form of p power x minus 2, p power 2. Then q power n minus x plus np. That's all. Then here compare. The denominator gets x into x minus 1. Here numerator gets x into x minus 1. To cancel the both value, then summation x is equal to 2 to n. So remaining numbers are n into n minus 1. This is then p square, then n minus 2 x minus 2 p power x minus 2 q power n minus x plus np. Okay. Have you understood? Here p value right before the n value. Okay. Next, n into n minus 1 into p square are all constant taken outside because n and p are parameters. Okay. Then summation x is equal to 2 to n minus 2 divided by x minus 2 p power x minus 2 q power n minus x plus np. Okay. So compare this term to one result. Before starting the derivation, by giving one result, the n minus 1 x minus 1 into p power x minus 1 into q power n minus x means equal to q plus p power n minus 1. Here n minus 2 appears. So change the result n minus 1 into p. This is fully equal to q plus p power n minus 2. Okay. Applying the result. Okay. Plus np, which is equal to n into multiplying the value n into n square minus n into p square. This is fully 1 because p plus q is equal to 1. So 1 power n minus 2 1 plus np. Okay, this is an important derivation, which is equal to multiplying p inside p square n square, p square into n square, p square n square, then p square into n minus p square n plus np. This is your expression of x square. Okay. Now the variance of x is equal to expression of x square. Expression of x square is this: p square n square minus p square n plus np minus expression of x square. Expression of x square form is np, already derived. So np the square, np square. So which is equal to p square n square minus p square n plus np minus square n square p square. So giving the square n and p, we get n square p square. So p square n square minus p square n square are cancelled. So remaining terms are these two. So taken outside, p n is common or np is the common. Here also np, here also np. Then the positive term, this is 1 fully taken outside. So 1, this is minus pn taken outside. So remaining 1p exists. So p, which is equal to np. This is equal to q because p plus q is equal to 1, q is equal to 1 minus p. So 1 minus p equal to q, 1 minus p is equal to q. So this is your variance of x, and means equal to expectation of x equal to np. These two are your result. This is the derivation of mean and variance of binomial distribution. Have you understood the derivations? Okay. Next class we have discussed the Poisson distribution. Okay, thank you. God bless you.